Hi students, welcome to our physics class. This is current electricity NEET class 1. In this class I am going to discuss about how to simplify a complex circuit by using mirror symmetry. Well, let's start today's class. So actually here we have to find out the effective resistance between the terminals A and B. Find the equivalent resistance of the circuit across terminals A and B. So look at the circuit. First, here we have to consider an imaginary line. So here we have to consider an imaginary line. Okay, so like this. So this is an imaginary line. So actually, this line divides the circuit into two equal parts. So this is the left part of the circuit and this is the right part of the circuit. Actually, the right part is the image of the left part. If we place mirror here, the right part of the circuit, this is the image of the left part. So both parts are identical. Okay. So actually, a resistance can cut only in a vertical way. So we can't able to cut the resistance in a horizontal way. We can't able to cut the resistance in a horizontal way. Actually, this is wrong method. A resistance can cut only in a vertical way. Okay, so this is right method. So if we cut this resistance in a vertical way, so what happens? Or actually that is divided into two equal parts. So this part having resistance R by 2, this part having resistance R by 2. In a similar way, so here is also the resistance is cut into two equal parts. So this part having resistance R by 2, this part having resistance R by 2. Okay, so this is the left part of the circuit. This one is the right part of the circuit. So first here we have to find out the effective resistance of the left part. So the effective resistance of right part, that is also same because both are identical. Suppose R1 is the effective resistance of the left part. So R2 is the effective resistance of right part. So here R1 that is exactly equal to R2. So first we have to find out the effective resistance of the left part. Okay. So if we cut the resistance R, so what happens? This part having resistance R by 2. So this part having resistance R by 2. So here is also the resistance is R by 2. So after that, let us consider an imaginary line here. And we will get the circuit like this. Now look at this circuit. So here R by 2 and R. These two resistors are connected in parallel. So if the resistors are connected in parallel, so what is the effective resistance? 1 divided by, what is the formula? 1 divided by RP. Let us consider here effective resistance of this parallel combination is RP1. Okay, 1 divided by RP1, that is equal to 1 divided by R1, that is R by 2. Okay, plus 1 divided by R. So 1 divided by R by 2, that is 2 divided by R plus 1 divided by R. So here what is the LCM? LCM is R. So 2 plus 1. 2 plus 1 is 3. So finally, we will get value of RP1 is R divided by 3, right? So the effective resistance of this parallel combination is R divided by 3. Okay, the effective resistance of this parallel combination is R by 3. Even the effective resistance of this parallel combination is also R by 3, right? Because here R and R by 2 both are connected in parallel. So what is the effective resistance of this parallel combination? That is also R by 3. Okay. Now look at the simplified circuit here. So this one having resistance R by 3. Even this one is also having resistance is how much? One is also having resistance is how much? That is also R by 3. So R by 3 and R both are connected in R by 3 and R both are connected end to end. Resistors are connected here end to end. That means R by 3 are connected in series. So if the resistors are connected in series, what is the effective resistance? That is R1 plus R2. So here effective resistance of this series combination, that is RS is equal to R plus R divided by 3, right? So what is the LCM here? LCM is 3. So here what is the value? 3R plus R. Okay. So 3R plus R is how much? 4R. 4R divided by 3. So the effective resistance of this series combination is 4R divided by 3. So the effective resistance of this one is how much? So here R by 3 and R again connected in series. What is the effective resistance? 4R divided by 3. So finally here 4R by 3 or 4R by 3. 3 resistors are connected in parallel, right? 4R by 3 or 4R by, so this is 4R by 3. This is the effective resistance. 4R by 3 or 4R by 3. All 3 are connected between 2 common points, means all 3 are connected in parallel. Okay. So the effective resistance of this one is 4R by 3. So finally, we will get the circuit like this. This is 4R by 3. This one is R. This one is 4R by 3. 4R by 3 or 4R by 3. All 3 are connected in parallel. Okay. So now the effective resistance is considered, that is R1, right? 1 divided by R1 is equal to 1 divided by 4R divided by 3, okay, plus 1 divided by R plus 1 divided by 4R divided by 3. So 1 divided by R1 is equal to 3 divided by 4R plus 1 divided by R plus 3 divided by 4R. So 1 divided by R1 is equal to 3 divided by 4R plus 3 divided by 4R is 6 divided by 4R, right? Plus 1 divided by R. So 2 2s are 2 3s are. So what is the LCM here? 2R, the LCM is 2R, right? So here we will get the value 3R, 3R. Okay. So actually here we will get what is the LCM 2R. Here we will get the value 3 plus here we will get the value, so that is 2. 2R into 1 by R. So R cancels, we will get 2. So here, so 2R into 3 divided by 2R. So 2R cancels, we will get 3. So 1 divided by R1 is equal to 3 plus 2, that is 5 divided by 2R. So what is the value of R1? R1 is equal to 2R divided by 5. Okay, so this is the effective resistance of left part of the circuit. So what is the effective resistance of right part? That is also 2R divided by 5. Okay, so the effective resistance of the left part of the circuit is 2R divided by 5. The effective resistance of the left part of the circuit is 2R divided by 5. Even the effective resistance of the right part of the circuit, that is also 2R divided by 5. So now R1 and R2, so both are connected in series. So what is the effective resistance? Rs is equal to 2R divided by 5. What is the formula? R1 plus R2, right? 2R divided by 5 plus 2R divided by 5. So the effective resistance between the terminals, across the terminals A and B, is considered, that is AB or AB. 2R by 5 plus 2R by 5 is 4R divided by 5. Okay. So this is the effective resistance. This is the effective resistance across the terminals A and B, or AB, that is equal to 4R divided by 5. Okay. Thank you.